Okay, so we double checked ourselves with StatCrunch and we see that this p-value is 0.7152. So what's happening there is, let me get you kind of a picture. This isn't quite right. So what's happening is that over here you've got what was it, 6.9? Hold on. Oops, I'm having issues. Hold on. All right, there it is, 6.9. And then there's an other value over here. You don't really know what it is because you're not going to bother to calculate it because everything's not symmetric. You can't figure it out easily, so Excel kind of figures it out for you. Basically, what you did was you figured out that this area was 0.347 or something. Let me go find that. Oops, I mean 0.3576. That's what I mean. So you found that this area over here was 0.3576, and then you multiply it in 2. You say, okay, well, whatever this other side is, that's also 0.3576. So together, you get a p-value of p equals 0.751. I think that's what it was. 715. Oops, a little dyslexia. 715. Okay, you never really found this other value because it's kind of tricky to find, so you just didn't bother. Okay, so this is one thing where Excel is easy or StatCrunch is really easy. Okay, but that's sort of what we were doing for the p-value method. I know they seem very similar, but they're not at all. Oops, they're not at all. There we go. Okay, and I can't get you a better picture than that because the book doesn't keep a p-value picture because of course it's impossible to, well, it's not impossible, but we don't know how to find this other value. Okay, so let's keep this in mind. Since our p-value is so high, we are not going to reject h-naught. Okay, but it's not for the same reasons as the classical method. So we do not reject h-naught because the p-value which is equal to 0.715, is larger than alpha, which was 0.05, your level of significance, the probability of making that type 1 error. Okay. All right. And let me just reiterate how I did it in Excel because it's kind of confusing. So with Excel, what I did was, because this was on the low side, if it was on the high side, I would have done it differently, but again, you can watch the Excel videos for that. But I took chi-squared dist, and I took that test statistic. I took degrees of freedom, which was 10 minus 1, true. That gave me one tail, and then I multiplied it by 2 to get the other tail. If you're working off of old Excel, you'd have to use chi-dist, this function right here. And then you say 6.49, comma, degrees of freedom, which would be 10, take away 1. See? Messy, right? And it doesn't work pretty. And to be honest, I don't even remember the way to fix it because it's such a nightmare. The old chi-square functions were really awful in Excel. That's why the new one's so nice. The chi-sq.dist, that one's much nicer. But if you're freaking out about it, don't have a heart attack. Just come over here and do it. Do it with StatCrunch. Variance, one sample. We had data in this particular problem. Verbal. Oopsie, not that one. Go on, cancel. False, fails, stop it. Data, one sample. There we go. Data. Verbal. Next. And then just remember you have to do variance here. You can't do standard deviation. Pick whether it was a two-tailed or whatever and calculate. Done. Simple as that. And it figures everything out for you. And life is grand. All right. All right, we are done with 10.5, I believe. Yep, all done. And we learned that it can get tricky finding the p-values for these things. If you're doing the p-value method, it's great still, but I totally recommend StatCrunch for this. It's just kind of a pain otherwise. All right, we are done with 10.5, and next time we will do 10.6, and it'll be all over. I'll see you then.